Okay, so as Tina just explained, Seydou Niang was unfortunately not able to make it today. He's a professor at Dakar University and he had some last minute issues with his visa. So I'm actually presenting his slides. He emailed them to me. So I apologize in advance if I'm not 100% familiar with them. I'm really familiar with the project, so I'll be able, I think, to answer all of your questions. But if you have some really technical details, we might need to follow up with an email. So this is the team. Oh, sorry, let me just go back and introduce the title. So we've turned all the projects in Senegal Dar, which in French is the Dechet resort from waste to resources. And most of the research there is focused currently on drying beds, both planted and unplanted. So the program is led by Seydou Niang from University of Dakar, and it's conducted in collaboration with myself and with Dr. Mbayam Bagere, who works for ONAS, which is the National Sanitation Utility there. We currently have 4 PhD students working on 3 general topics. So the first one is Jean-Biron, who's working on sustainable sanitation fee structures. Then we have 2 students working on planted drying beds, Alhaji Mamadou Sonko and Amadou Gay. And they're also working on increasing fodder production so that they can sell plants that are produced during treatment. And then we have Alsan Sek, who's working on unplanted drying beds and trying to maximize the dryness of sludge so that it can be co-combusted as a fuel in industry. So the overall goal of the DAR project is adding value to fecal sludge management technologies in sub-Saharan Africa. So to demonstrate the technical and financial viability of using fecal sludge as a value end product, and then also to specifically develop financial flow models for implementing reuse-oriented fecal sludge management in Senegal. So just to give you some specific context about Dakar specifically, there's 2.5 million residents. 65% of the population has access to adequate sanitation. 25% of the population is served by sewer systems. There's 2 sewer systems in Dakar. One goes to a wastewater treatment plant at Cambrai, where there's activated sludge, and the other one just goes directly into the ocean. 40% of the population is served by on-site technologies, which mainly means septic tanks. So a large number of on-site sanitation systems have been built because they're relatively inexpensive to set up compared to the sewer. But in reality, at the household level, adequate management and appropriate management is actually more expensive than the sewer due to the cost of emptying. So the sewer tax is based on drinking water consumption. So everybody is paying for the sewer, but the people that are served by on-site systems are in addition paying to maintain their systems. So they're basically paying twice for sanitation systems. On-site technologies without adequate money for proper management obviously leads to self-management. And the picture on your right just shows a household level user that just dug a hole in the street and emptied their system there. And the result is, of course, environmental pollution, increase of human health risk, and groundwater contamination. Here's a neighborhood in Senegal where, and I put a question mark because I wasn't actually able to fact check this number with Seydou, and I don't want to state it as a fact until I fact check it because it seems quite large. But in this neighborhood in Dakar, on-site systems it's estimated, are currently contributing 15,000 cubic meters per day to groundwater recharge, which is the same quantity of water that was actually pumped from groundwater in the 1970s to supply Dakar with all of their drinking water. Anyway, I'm not certain about the number, we'll check that, but the point is it's very significant. And what these pictures show is the picture on the left shows the construction of a septic tank. And you can see it's being built above ground because there's such a high water table. And I don't know if you can see the picture on the right. That is the outlet pipe on the right-hand side at the top. So it's just draining from the top of the tank directly into the street. There's no leach pad or anything. Okay, so what's the topic today? We're going to present briefly some results from each of the 3 topics that the students are working on. First, the sustainable sanitation fee structures, then the planted drying beds, and then unplanted drying beds. So in terms of the first topic, sustainable sanitation fee structures, this is a paper that recently came out, and it actually predated John Biron's PhD work, and he's now continuing on from here. So this was comparing the capital and operating costs of fecal sludge management versus sewer-based systems. And Dakar was provided a unique opportunity to make this analysis because they exist side by side in the same place. And if you tried to compare these two totally different types of systems in two different cities, there's just too many variables to compare. So from here now, John Biron has conducted studies in Ghana, in Burkina Faso, and Senegal, and he's just completed his field work and is now starting to analyze his data, and hopefully will soon come out with some publications. The second topic is planted drying beds. These barrels that you see are the ones that Sanko is using for some pilot scale studies to look at effects of different things. So this is a literature review slide that Sanko put together, was sort of justifying the research that he's doing, is how do we operate planted drying beds. So in Europe, several studies have been conducted. The technology is reasonably well established and results are available, so we know sludge loading rates depending on climate, loading frequencies depending on weather conditions and climate, how to handle different types of sludge, and how to use different types of plants. But in sub-Saharan Africa, and specifically using fecal sludge, the technology is still in the experimental stage, and really most of the research has just been done by Yves Kenye in Cameroon. So the only results to date are that we use sludge loading rates for about 100 to 200 kilograms per cubic meter per year, and Yves did his work with the Kina Kloa. So Sanko wanted to ask, how can we make these results more relevant to the sub-Saharan context and have reliable information? So this is sort of the experimental setup for his PhD, where he's looking at treatment performances and humidification processes. And he had 3 different studies that each ran for 6 months. The first was looking at loading frequency. So the rate was kept the same, but the beds were fed either once a week, twice a week, or 3 times a week. Then he tried 3 different types of plants, and then also varied the type of the type of sludge that was coming in, either raw fecal sludge directly from trucks, or the emptying trucks, or thickened sludge following primary settling, or sewage sludge, just so we could compare the results. So today we're just talking about the first paper, which he's working on writing up now, which is loading frequency. So this was how he set up his system. You saw the pictures of the barrels in the slide a couple back that I pointed out. So he planted the plants, he filled the barrels with coarse gravel, medium, fine gravel, and sand, just like a drying bed. Then he planted the plants and got them acclimatized to the fecal sludge, started watering first with tap water, and then gradually stronger and stronger and higher loading rates of fecal sludge till he got them acclimated. And if you've worked with planted drying beds, you know this startup period is very important. So then now here are some of his results. He found that the density and stem diameter of the plants increased with the loading frequency. After harvesting, the density of the plants was higher, but the plant stems were actually thinner, just because when you cut them all down and they're growing back rapidly, they're smaller. And loading once a week resulted in reduced plant growth due to wilting. Also, this slide is a bit confusing. It's a lot of data presented all at once, but what you see in the black line is the actual raw sludge that's coming into the system. So it's extremely variable because it's coming from these different emptying trucks, but is also representative of reality in Dakar. And what you see in the top lines are the total solids concentration in the leachate coming out of the bed. So the total solids in the leachate varied with the load that was put on, but not proportionately. So we saw that the beds were relatively resistant to shock loadings. And these are some of the conclusions then altogether, was that increasing the loading frequency reduced the volume of sludge applied at one time, and he found that that also resulted in less clogging. So there was less ponding of water on the surface of the beds. As we said, the increased loading frequency also enhanced plant growth. The removal rates, or what's present in the leachate, was not directly proportional to the loading rate. And also, there's not a I didn't show a figure of this, but the increased loading frequency also resulted in increased nitrification. So the conclusion is that for fodder production, loading 3 times a week is much better than 1 to 2 times a week. This is from the second student. This is a study that he just conducted looking at identifying local indigenous plants that have never been used before in drying beds to see if they could be used for profitable end use. So the first thing he did, this was a pretty good PhD topic, he got to travel around Senegal and just look for plants that grew in areas that seemed promising that they could also grow in treatment wetlands. Then from there, he also conducted surveys with people, socioeconomic evaluation, to find out if they had beneficial, profitable end uses, the different plants. So he asked people about crafts, because they use the plants a lot for weaving mats and fences, food for livestock, and also the treated sludge production for agricultural use. So based on this, he identified 7 species. I'm just going to run through them quickly. So you can see these are from some pot trials he did later. It's a variety of different plants. Then he put together this evaluation matrix because we decided that we only had enough resources for him to test the optimal 3 plants. And so based on these cultivation tests, he decided to do the market demand analysis. Had the plants been tested in planted drying beds before, because he wanted to research something that had not been done before, and then their overall morphological appearance and how that would affect their end use. So this was the initial pot studies that he did, where again he planted all 7 of the types of plants and he acclimatized them for 2 weeks with water, 3 weeks with leachate, and then fed them for 4 weeks with faecal sludge, and just measured general characteristics of density, death rate, and height. Okay. What he found was that 5 of the plants grew really well in only 2 minutes. So I'm not going to actually go through results in more detail than that. This is just qualitative data on root density. The plants growing with faecal sludge have smaller roots because they don't have to grow as much to look for nutrients or water. So in conclusion, he found that 5 plants grew well with the faecal sludge and 2 just suffered and died. So based on his grid selection, then he's doing further analysis on 3 optimum plants, and he's just going to do some follow-up small-scale studies first using actual loading rates before he goes to the full-scale implementation. And this is the final one where we have a student looking at greenhouses and passive ventilation to increase drying of faecal sludge so that it could be used as a combustion for industrial fuel. And the industry that we're working with has stated that they need the sludge to be 90% dryness for them to take it. So again, we have these drying beds that are 2 meters by 2 meters, and he set them up with these greenhouses that have 2 chimneys on the top. These are the analytical methods he looked at. So the results found that the first test with passive ventilation with just the chimney actually increased the amount of moisture in the sludge because it trapped the humidity. So this was not a good result. So then the next thing he did was open the area around the bottom to increase ventilation, and that resulted in no net benefit, but was better than the previous one. So then he actually put in ventilation where there's 1 fan extracting air and 1 bringing in fresh dry air. And then he found that he did have increased performance. But it also rains during his study. And so now the question is, was the increased dryness effect of the greenhouse, or was it the effect that the greenhouse was basically an umbrella, keeping the sludge dry from the rain? So he's now replicating this study. This just also showed that the temperature was higher in the greenhouses and also the humidity was lower. So it seems like there is a good potential there. But he's just doing some final tests now. This just shows in the middle in the blue and white rainfall data for Dakar. You see it doesn't rain very often. So hopefully by the end of November, he will have conducted these final tests. And this is the pilot scale that we're working with. Following my presentation, Swaib Semiaga from Makerere University will also present market demand results. And then following him in the main room will be Teddy Nakata with the calorific value results. And with that, I will conclude my presentation.